Senior Director of Security Strategy, Governance, and Oversight. Today, I'll walk you through my S3-based bulk data migration pipeline for email retention systems built entirely on AWS serverless technologies. This project demonstrates how to migrate email data at scale with full integrity, auditability, and compliance. I'll cover the architecture, implementation steps, and governance and compliance value this solution provides. Why I built this? Organizations often need to migrate large volumes of email data for retention, e-discovery, or regulatory compliance. Manual migration is error-prone and hard to audit. My goal was to create scalable, auditable, and fully automated pipeline using AWS so migrations are reliable, secure, and easy to validate. Let's look at the architecture. Emails are organized in S3 source bucket by tenant, mailbox, and date. A JSON manifest tracks all emails and their MDM checksums for integrity. AWS step function orchestrates the workflow, triggering Lambda functions for processing. Amazon SQS enables parallel Lambda innovations for high throughput. The DynamoDB tracks migration status and errors. AW Glue and Anthea provide validation and reporting. CloudWatch offers real-time monitoring. The serviceless approach means the system automatically scales with workload, and you only pay for what you use. Here is a visual architecture diagram. Step 1. I started by creating two S3 buckets, one for the source and one for the target. Both use server-side encryption, versioning, and private access. This enables the data to be secure and changes are tracked. For step 2, to stimulate real migration, I wrote a Python script that generates 1,000 test emails organized by tenant mailbox. Each email includes MD5 check some integrity. The script also creates a migration manifest, a JSON file listing all emails and their metadata. I uploaded everything into the S3 using AW CLI. Here is the Python script. All the way down here. Okay. For step 3, I created a DynamoDB table called email migration status. It tracks each email migration status, timestamps, and errors using on-demand capacity to avoid throttling. This table is a single source of truth for migration and process. For step 4, I built several Lambda functions. Email copy worker. This one's triggered by SQS. It copies emails from the source to target and validates the checksum. Manifest processor. This one reads the manifest and sends the SQS messages in batches. Migration status checker. This one monitors migration progress and reports to step functions. The DynamoDB to S3 exporter. This one exports the status data for Anthea queries. All Lambda functions are using Python 3.12 and are stateless, and they scale automatically. For step 5, a standard SQS triggers Lambda workers for parallel processing. There's also dead letter queue for error handling. If a message fails 3 times, it moved for the manual review. For step 6, step functions orchestrates the migration. The state machine processes the manifest, waits 30 seconds, checks status, and loops until all emails are migrated. It includes error handling and retry logic for resilience. Step 7. Glue crawlers and Anthea-enabled SQL-based validation and compliance reporting. After migration, the DynamoDB data exported to S3, crawled by Glue, and queried by Anthea to verify every email was migrated correctly. In step 8, a CloudWatch database provides real-time metrics on Lambda innovations, errors, SQS activities, and workflow execution. This makes monitoring, troubleshooting easy. This architecture delivers scalability because serverless design handles thousands to millions of emails. Security, encryption, private buckets, and least privilege identity and access management was used. Data integrity, MDM checksum validations for every file. Audit trail, the DynamoDB tracks every single migration event. Fault tolerance, dead letter queues, and retries for resilience. Validation, Anthea queries for compliance checks. Observability, CloudWatch for live monitoring. Cost-effective, you only pay per use, no idle resourcing. It's a model, a cloud-native solution for regulated industries. From a GRC perspective, this project provides hands-on understanding of technical controls, risk factors, and oversight for a large migration. It demonstrates how to implement strong audit trails, validate data validation, error handling, key requirements for regulatory compliance. In summary, this project delivers a production-ready serverless migration pipeline for email retention, e-discovery, and compliance. Thank you for watching today.